Hi everyone, my name is Anna and today I'm going to give you an overview of the Materials Science and Engineering department here at Virginia Tech. So I am a junior here in the department and I have a minor also in green engineering. So today basically I'm just going to go over our curriculum and what career opportunities you can get from Virginia Tech. So the materials engineering curriculum is very broad, but it's focused around 4 core materials: metals, polymers, ceramics, and electronic materials. So the way our curriculum works is you take a class in each of those materials, and then once you figure out what you like, you can choose the rest of your classes based on that. So those are the 4 main classes that everyone takes, but then you have to fulfill a certain amount of technical electives after that, and you can choose from nanomaterials classes, biomaterials, nuclear materials, composites, powders, glasses. You can choose any type of material after that, or you can stick with one of those 4. So that's kind of how we take a really broad curriculum and condense it down so that everyone gets a good basic education on the 4 core materials, and then you can just choose your path. So within studying those materials, we learn about the properties and the structure of each of them. So these are really important in knowing about materials so that you can choose what they're supposed to do. So knowing how to select the appropriate material for any application is very important, and we can't do that unless we know the properties and the structure of each and what those mean. So learning all this complex stuff about materials is really, really awesome and really great to get lectured about, but you can only really apply it in a lab. So that being said, our materials department is one of the most hands-on engineering departments at Virginia Tech. From the time that you begin your materials science education, like from your first semester in the major, you are in a lab, and then you are in a lab for every semester after that. So that's something that really, really enhances your education and is a great way to apply what you learn in the classroom outside of the classroom. So we're studying the different strengths and weaknesses of certain materials, and then next day in lab, we're applying that, we're testing that, we're seeing if the theoretical strength of something is the same as what we get in the lab. So this is a really awesome way to kind of just support and boost the learning that you're doing in the classroom with hands-on learning. So that being said, we also have a really unique thing here at Virginia Tech. We have a foundry on campus. So a foundry is where you go to learn about metallurgy, and you get to actually pour molten metal. You get to learn about the properties and how to quench metal and things like that. So that's a super, super unique opportunity. Not a lot of campuses or departments can say that they have that, and another great way to get involved with hands-on learning. Obviously, this is a super broad major because everything ever is made of materials, which means you can get into pretty much any industry. You can do design, you can do aerospace, automotive, you can work with biomaterials, you can go straight into metallurgy, you can work in defense, you can work in manufacturing, you can work in semiconductors. Literally, the list is endless because, like I said, everything around you is made of materials. So this is really cool and a great way to just get perspective on something that you're passionate about and what direction you can take it. The opportunities are endless. So a story we usually like to tell to kind of enhance that is about football. So in 2007, the Virginia Tech football team made it to the ACC championship, and our star running back before the game, Cedric Hume, he broke his arm, and he wasn't going to be able to play in the game because a typical cast is ruled as a weapon by the NCAA. So the football team approached the materials engineering department and asked us to create a cast that wouldn't be considered a weapon, but that would still protect our running back's arm. So obviously the engineers pulled through, they made a cast, and it got cleared by the NCAA. So Cedric Hume played in the game, and the football team won the 2007 ACC championship. So we like to say that materials engineers also win football games, but that's just an example of a way that your passion can be a part of your career. And then a little bit about our other hands-on opportunities. We have 3 design teams housed under the department, and then materials engineers can get involved in any other design team. But one that I'm a part of is the ceramic disc team. So we make a disc out of any ceramic and we bring it to a competition every year, and then it competes in an aesthetic competition and a disc golf competition. So here's a little piece of our disc from last year. This actually took first place in the aesthetic competition and the disc golf competition. So we're really proud of that, but it's just a cool way to be able to take what I learned in ceramics class and ceramics lab and make it into something physical that we can go compete with. Again, another cool way to get involved with hands-on activities. And then some of the work that I've done, I have had 2 internships with GE Aviation working on composites. So the whole goal of my job the past 2 summers has been to help them create composite ceramic parts that are replacing metals in plane engines. So that's been super cool, definitely applying all my knowledge that I've gotten from the classroom there.